Hey y'all, it's your main math teacher, Mr. Boyden, back at it again today, and today we're going to start Unit 2 of our IB video series. Alright, today we're just going to work on basic skills, okay? It's things that you've probably already learned before, but perhaps you forgot them over summer, but they are things that we will need to know going forward. So let's begin. First, we're going to talk about the Cartesian plane. All that really means is our two-dimensional graph that we've been using for years, okay? Any graph with an XY axis is going to have 4 quadrants. We need to know which one is which. Alright, now, it surprises some people. Well, maybe the first one's not surprising. This is quadrant 1. I'm using Roman numerals. That's the typical notation we use. A lot of people want to move like a clock. They want to go clockwise, or they say to the right. It actually goes counterclockwise for reasons which we'll discuss in Unit 4, I believe. Okay, so this goes 1 and 2 and 3 and 4. Okay, and what could we note about those? In quadrant 1, both the x and the y value are positive. In quadrant 2, since we're moving to the left, the x value is negative and the y value is positive. In quadrant 3, both of them are negative. We're going left and down to get there, so both negative. And in quadrant 4, we have a positive x value and a negative y value. Okay, so that's good to note before we get on to questions like these. All right, we're going to answer in which quadrant are we referring to in each of these 5 examples. All right, so I'm just going to draw a little xy axis over here. All right, what about negative 2, 3? Negative 2, 3 would be left and up. Okay, that's an easy one. That's quadrant 2. Okay, what about this one? X greater than 0, y less than 0. So positive x values, negative y values. So positive x values is to the right, negative y values is down. That's quadrant 4. All right, what about negative x values and negative y values? That's left and down, so we're talking about quadrant 3. And then this is where it gets kind of exciting. So we have x over y, and we're getting something less than 0. So I'm going to just make a note that x over y is a negative number. So what we have to think about is how could we divide two numbers and get a negative result? Well, either we could have negative divided by positive, or we could have a positive divided by a negative. Those are the only two ways. So we have to think about how that would work. So going back to what we talked about a minute ago, if we have positive positive here, we'd have positive divided by positive. Okay, that's not negative, so that's not our solution. What about here? We had a negative and a positive there. Hey, that matches this case. So quadrant 2 is an answer to part D. Okay, but we're going to keep going and double check. This is negative negative. Okay, that doesn't match. And this is positive negative. Oops, negative. So that does match. So this actually has two answers to it, quadrant 2 and quadrant 4. All right, what about this next one? X is 0, y is positive. X is 0, y is positive. Okay, that actually puts me on the y-axis. So this isn't referring to a quadrant at all. This is actually referring to the positive y-axis. Okay, now that's in there is just a little bit of a trick question just to make sure you're thinking about it. That's this collection of points up here, not down here because y had to be greater than 0. So always be careful when you're reading questions to make sure you understand what they're really saying. Another skill that will be important this year is simplifying radicals. Okay, the easiest way typically to do that for most new learners is to make a factor tree. So it's as easy as this. You take the number that's sitting there, the quantity, a lot of times there will be variables as well, but that's okay. And you ask, okay, what could I multiply together to get that? How about 5 and 10? Okay, what about 10 breaks down into 5 and 2? And then we look at the terminal numbers. Now what I mean by that, the numbers that are at the end of a branch. Okay, I can't break down 5 and 5 or 2 anymore. So I'm going to try to pair them up. I have a pair of 5s and a 2. So what does that mean? That means 50 is the same as 5 squared times 2. And it has a root over it. So then I can break those up with their own root. So that would be 5 squared with a root times the square root of 2. And what happens here is you have a root and a square that cancel out. So this simplifies to 5 root 2. Now, for the moment, that may not look more simple than root 50. It's the exact same numbers as symbols, in fact. So you're going to have to take my word for the moment that this is more simplified because we're expressing a smaller quantity, and we'll see later why that's important. Okay, what about the next one? If the first one made sense, maybe you could try the next two on your own. Okay, for this one, the way that looks easy to me is if I take 3 and 100. And actually, I realize right now 100 is a perfect square, so I don't have to keep going. Because if I represent this as 10 squared times 3, recognizing that each will get their own, so 10 squared, own root that is, times root 3, then what I get right here, square and square root canceling, and I get 10 root 3. All right, what about the third one? Root of 1,000. All right, I'm going to break this one down into 10 times 100. So there's 100 again. And what that allows me to do is rewrite this as square root of 10 times square root of 100. We know the square root of 100 is 10. Okay, and we generally don't write our answers out this way. For one thing, we can't tell for sure it's multiplication, and I don't want to have to put a multiplication symbol. Also, if we're sloppy with our radicals, we can't tell if 10 is under the radical or not. So what we'll do is we'll reorganize it like this. 10 root 10. Okay, and we'll call that good. These next two are some of my favorite things to teach at the IB level, distance and midpoint. And the reason I like them so much is because what I find is that most students coming into my class have learned this in a way that is far too complicated. Okay, if I wanted to find the distance between 2 points, sure, I've got this, and many of you already know there's a big complicated formula that does that, but it's far easier if we just draw in a triangle. So I'm doing my best drawing here, which is my best is not very good. Okay, and I've made a right triangle, and then all I'm going to do is figure out what the legs are, and that'll be easy to find the hypotenuse. So this one goes from 3 to 7. Now, y'all, I'm not going to use a formula. I'm just going to recognize that going from 3 to 7 is a distance of 4. And we can count the boxes, 1, 2, 3, 4. What about here? I'm going from 2 to 8 on the y values, which means I'm rising up 6. I could count the boxes if I want, although I don't. I just say, hey, I know that 2 to 8 is a distance of 6. And then what do I have? I have my hypotenuse here, and that represents the distance between the points. So we remember a squared plus b squared equals c squared. So 4 squared plus 6 squared equals, and in this case, I think maybe I'll go back and I'll call that d for distance. So that would be d squared. So what do I get? I get 16 plus 36 equals d squared. Okay, so what do I have? I have 52 equals d squared. And I'm going to introduce a square root here. And then I'm going to break this down. So what does 52 break down to? 52 breaks down into 2 and 26. And 26 breaks down to 2 and 13. And 13 is prime, so I'm going to stop. I have a pair of 2's here. So this simplifies to 2 root 13. Now, this might seem a little strange in the sense that I told you previously that anytime you introduce a root, you're going to have a positive and negative answer. Distance is a context in which that doesn't make sense. Negative distances are not meaningful. How can you be negative 3 units away from something, or negative 3 feet, or negative 3 miles? No, it's always going to be a positive number, so we'll always take the positive solution. Now, you could have used the distance formula for this. And the distance formula, yes, it exists, and many teachers just hand it to you, and they go for it. So I'm going to show you what it is, and then I'm going to show you why you never need to use it, because truly you don't. Okay, so there's a big old square root, and then they do x sub 2 minus x sub 1, and you square that, plus y sub 2 minus y sub 1, and then you square that, and then that is the distance. Now, for me, I really struggled when I saw this in about 10th grade, maybe 8th grade, wherever it was, because I'd get confused. Wait, is it minuses in there, or is it pluses in there, or is that one a minus, or is that one a plus, or what if I put the x1 first instead of the x squared, or the x sub 2, or if I put the y sub 2 there instead of the y sub 1, and then what if I mix the orders up and do the y's before the x's? All these things that were clouding my mind I had to think about. It's so much more simple than that, because all this says is how far apart are the two x values. That's literally all it means. This one is saying, hey, how far apart are the two y values? And then we're going to square those exactly like we did with the Pythagorean theorem. You add them together because it's a squared plus b squared equals c squared, and at the end you take a root. So this formula encompasses every move we made up here, but if you miss one little symbol, the game's over. I find it so much easier to say, hey, these are 4 apart and those are 6 apart. There's Pythagorean theorem, and we know that from about 7th grade, so we're already really good at that skill. So functionally, learning distance then isn't a new skill when we get to high school, but many of us overcomplicate it. Okay, so please don't overcomplicate it. Okay, what about finding midpoints? Finding midpoints is another one that's really easy, but people make it way too hard because really midpoints are as easy as this. If I say, hey, I have 0 and I have 10, would you tell me what number is halfway in between those two numbers? I bet most of you can recognize the number that's halfway between them is 5. Okay, it's not that hard. If I say 4 and 6, I'm willing to bet most of you can tell me that the number halfway in between those is 5. Because all we do is we have to find the average. Okay, and if you look over here, this is the actual midpoint formula. All it is finding the average of the x values. If I asked you for the average of 2 points, add them together, divide by 2. For the y values, add them together, divide by 2. Now, when I learn this, I get really frustrated because, wait, what if I do x2 first instead of x1? Or what if I do the y's and then the x's? Okay, first of all, this is addition, so the order does not matter. It does not matter which x value you pick first. My second thing I would mess up is I wouldn't remember which is x and which is y. Hey y'all, it's as easy as this. When you're looking at coordinates, x comes first. So guess what? X comes first, comma, hey, it's the same comma, and then y. Let's apply that here. Okay, so what I get here is I get my x values come first. So 3 plus 7 over 2, I'm just finding the average of them. And then I have 8 plus 2. Just finding the average of them. Okay, dividing by 2. And I'm not even looking at that formula because I'm just remembering I'm finding the average. Okay, so 3 plus 7 is 10, divide by 2 is 5. 8 plus 2 is also 10, divide by 2 is 5. And so 5 is my midpoint, and I can verify visually that that's true. Okay, so rather than memorizing a bunch of formulas, I would like you to keep in mind that distance is just the Pythagorean theorem. And I'd like you to keep in mind that midpoints is just finding the average of two numbers. That's all it is, okay? And if you can keep that straight, then it's not too bad. So let's do an example. Finding the distance between and the midpoint of these 2 points. I think this would be a great time for you to pause the video and try this on your own, and then hit play and see how you did. All right. For distance, I'm going to start with my x values, and the question is how far apart are 6 and -3? Now, if you're able to look at that and know that it's 9, wonderful. If you're not, just subtract one from the other. It does not matter which one you put first, okay? So 6 minus -3, that would be a distance of 9. Okay, so 9 is that, like I said it would be. 2 to 5, I bet you can do that mental math. That's a distance of 3. So that'd be 9 squared plus 3 squared equals distance squared, or 81 plus 9 equals distance squared. That's 90 equals distance squared. We're going to take a root. And so that breaks down into 9 times 10, and 9 breaks into 3 and 3. And I'm going to leave 10 alone because that's not going to simplify. So what do I get then? I get 3 root 10. That's the distance. What about the midpoint? That one, I'm just going to add these together. And guys, I'm not even going to show the setup. I'm going to talk you through it, but you don't even have to write it. So 6 plus -3, that gives you 3, and it's over 2. 2 plus 5 gives you 7, and that's over 2. The only thing you got to keep straight is I needed to do the x values first, and then the y values second. So 3 over 2, 7 over 2. Y'all, that's the whole midpoint. You can do it as a decimal if you want, but I'd prefer that you leave it as a fraction. And the last thing for today's video, do we remember what isosceles means? All right, isosceles, it's typically used to describe triangles or trapezoids. Okay, and all it tells us is that two sides are the same length and that one side is different. So maybe these are 3 and maybe that's 2. In terms of a trapezoid, all right, best drawing coming right up. Okay, what it tells us is that 2 of the sides are the same and the other sides are different. So maybe this is 3, 3, 5, and 7 or something like that. Okay, so in your assignment today, you are going to see there's that word's going to come up. This is all it means, okay? Hope you enjoyed the video today, and we'll see you next time.